Welcome to this video lesson. We're going to do some practice questions on two-dimensional vectors. In the first question here, we're asked to determine the east and north component of the following vectors. So we have two, and note, actually, I'm going to add this. Note, when we use the keyword determine, we're saying this means to provide a final answer and show all the necessary work required to get there. So we need to make sure that we are showing all the work and not just writing a final answer. So here, the first one, I have a vector which has a length or a magnitude or size of 40 meters, and it's at a 70-degree angle, and here is my north and east. So east is to the right and north is in the up direction. So I can break this down into two components. The two components are going to be, one is going to be in the north direction, so in this direction, and the other one is going to connect this way to here. So this one over here, so I'm going to call this vector A, and this is going to be A in the east direction, and this one is going to be A in the north direction. And what I'm trying to do is to find the magnitude to those. So what I have here is a right angle triangle because this is north and this is east, and they make 90 degrees. And we can do this the long way or the short way. Let's start doing this one long way, and we'll do the second part the shorter way. So basically I have the hypotenuse, so I can use either sine or cosine to get to get this question started. So sine of my angle 70 degrees is going to equal to the opposite. In this case, the opposite is the east component. So that's AE, and I'm going to divide that by the hypotenuse, and in this case, the hypotenuse is 40. So now I can multiply both sides by 40, and I will get 40 times sine 70 degrees. And assuming that our calculator is in the right mode, we should get that this component is equal to 37.587. And to get the proper vector component, so AE here, is going in the same direction as my positive east direction. So I'm going to use a positive value. My values here are true to three significant figures, and therefore my final answer should also have three significant figures. So I'll leave it as 37.6. And I'll put an estimation because I rounded it. I will also box my answer so we know what that answer is. Now, in order to get so this was a long way. The long way is actually including this step. You can directly go to this step and say this is the opposite side. And since I have the hypotenuse and since it's opposite, I have to use sine. So 40 times sine 70 will give me that. So once you get really good at this, you can start skipping this step. We can use the cosine. So cosine of 70 degrees is going to be the adjacent side. This one is the adjacent side over here. And adjacent is the north component divided by the hypotenuse, which is 40. And we're going to multiply both sides by 40 to get 40 times cosine of 70. And that is going to be, and this is dot, 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 this is going to be 13.6808 dot, dot, dot. And I'm going to express this one as well over here as a vector. And this vector is also rounded to three significant figures because that's the lowest number of significant figures that I have from my numbers. And since this direction is in the same direction as my north, it's going to be positive, and it's going to be 13.7. And my units is going to be meters. So I forgot to include my units in the last one. So, and this is also in meters. Okay, let's do the next question now. The next question, we're going to use the shortcut right away, but we are going to draw out our components. So our components always make a 90-degree angle, and the vector itself is always the hypotenuse. So this is going to be the adjacent side. This is going to have a magnitude of AE, and this is going to have a magnitude of AN. The directions we'll take care of later. Let's just find a magnitude using, the magnitudes using some trig ratios. So this side over here is opposite. So in order to find AN, I have to multiply the hypotenuse by the sine of 60. And this is going to be 25.98 dot dot dot. And to find the east component, or the magnitude, just the size of it, I have to multiply the hypotenuse, since this is adjacent, by cosine of 60. And when I do that, I will get 15. So to express my final answer, I know that AN, the vector, is actually going in the opposite direction as my north side. So this is the positive side, so this has to be negative. So this is going to be negative 25. Actually, no, I have to round. Since this is an 8, I have to round this to a 0, so this becomes 26.0. My unit is meters. And the direction is north. Actually, I don't think I included my direction in the last part, so I'll go and do that now. So this is going to be direction east, and this is going to be north. And for the east direction, I have 3 significant figures. So this is 15.0 meters, and this is in the east direction. But since it is in the east direction and this is going in the opposite direction, put the arrow there, it's negative. And I'm going to box my answer over here. For the next questions, we are asked to sketch vector A, which is 20 kilometers east, 40 degrees north, vector B, which is 10 kilometers west, 45 degrees south, and vector C, which is 15 kilometers south. Note that sketch refers to an image that gives the viewer a good representation of the situation with all the necessary components or information labeled. It does not have to be perfect. So when you're doing a sketch, you have to use the proper scaling, but it doesn't have to be perfect. You don't have to actually take a ruler and measure 20 kilometers. You can just estimate it and draw it out. When you're asked to draw, then you will often have to use a ruler or a grid to and kind of say what scales to what, and make sure that all your measurements are correct. So in this case, we are sketching. So in order to sketch the first one, vector A, it's 20 kilometers, and it's east 40 degrees north. So it starts here, turns 40 degrees towards north, so it goes this way. So I'm going to draw it with purple. So this is 40 degrees. And it's 20 kilometers, so I am going to label it as 20 here, and this is vector A. Now, for the next one, vector B is 10 kilometers west, 45 degrees south. So west is in this direction. 45 degrees towards south, that goes in this direction. So let's draw that out. And it's 10 kilometers. So in terms of length, if this is 20, this needs to be approximately half of it. So I'll do a little bit of erasing here. And I think that's about half, approximately. So I'm going to draw an arrow here. And this is vector B. And its length is 10 kilometers, and we need to show the 45 degrees. So this is 45, and I've drawn it here. You can also just, so in the question it says west 45 degrees south, so this angle is 45, but since this is 90 degrees, that means if this is 45, this is also 45, so it doesn't actually matter which one you label in this particular case. In this question, you could have labeled this one as 50 or this one as 40. And you don't need to include both, it just becomes less concise actually. I would actually only do one of them. Finally, C is 15 kilometers south. So to do this one, it's going the south direction. It is 15 kilometers, so it's a little bit longer than the 10. It's halfway between kind of this and this. So I'll draw it this long, maybe a little bit longer, but that's okay. Again, it's a sketch. And the information we need to give in, we don't need to give an angle for this. It is going in the south direction, and it's obvious that this is south since it's opposite of north. And this is going to be vector C, and it's going to be 15 kilometers in terms of length. And that's it for this one. So if it's a two-dimensional vector which has an angle, you need to make sure you include the angle and you have the size, and make sure that the size, if you have multiple ones, they're all scaled properly. So this should be twice as big as this, and this should be 1.5 times as big as this, and approximately. It doesn't have to be perfect. Again, it's a sketch. Now, in this question, we are asked to state the following in vector form. Note that state, or the key or the command term state, refers to us saying that the answer, to us stating the answer really, or saying what the answer is, without requiring to show any work. So we don't actually need to show any work when we do this. So let's do vector A first. Vector A here. See, sometimes you don't have to include the vector sign. In this case, A is just showing the magnitude. It's just saying that the size here is 3 meters, and the direction is shown by the vector anyway, so it's included there. So vector A is 3 meters, so I'm going to write its magnitude, its unit, and its direction. See, I've labeled this one as north and this one as west. I did this purposefully. It's not that I made a mistake, but I wanted to make sure that you folks know that it doesn't actually matter which way we label which things. We can choose our sign convention to be whatever we want. So in this case, since this is north, then that would mean that this is going to become south. For vector B, its magnitude is 4, unit is meters. Let's talk direction. Direction, it starts in the west direction, turns 20 degrees towards the south side. So west turns 20 degrees towards south. You could also label this, there's many different ways of doing this. You can do 4 meters, you can do it as south 70 degrees west, and that would mean that you have 4 meters starting from south, turning 70 degrees in this direction, and 70 and 20 make 90. And there's different ways too. You can also use a negative 4 meters and change west to east and south to north, or you can also represent it as negative 4 meters and change south to north and west to east. So for example, for this one, east is this way, turn 20 degrees towards north is this way, and then if this is 4 meters in this direction, then negative 4 meters is in that direction. So anyways, it doesn't really matter which one you show in terms of stating your answer. This would give you a mark for the first one. Any of these 4, given that they're correct, will give you 1 mark, and you don't actually have to state 4 different answers. Please don't, because it's just more to read and you just want one concise answer. You don't need to show them all. Finally, for the last one, again, state questions are just 1 mark questions most of the time because you only need to state one thing unless you're asked to state 2 things. Vector C has a magnitude of 5 units of meters and it's got a direction. We'll do one of the directions this time. Starting from north, it goes this way, turns 20 degrees towards east. So starts north, turns 20 degrees towards east. And this is a lovely, acceptable answer for this one. Let's look at the last question over here. We got the question says that given that vector A is 3 kilometers east, vector B is 2 kilometers west, 30 degrees north, and vector C is 1 kilometer south, determine vector A plus vector B plus vector C. Let's do this. First, I'm going to actually do a sketch. The sketch will help me kind of figure out what each vector looks like. So I'm going to take east to be in this direction and north to be in this direction, and those are going to be my plus. And this is going to be my sign convention. I'm going to circle it and highlight it and make sure that it's nice and visible. So vector A is 3 kilometers. You can see that that is the longest one out of these ones, so I'm going to draw that a little bit bigger. And it only has one direction. It's only going in this direction. This is vector A. And vector B is going to be, let's use a different color for B. B is 2 kilometers. This one is west 30 degrees north, so actually I will draw a little guideline here so that we can use it to come up with a nice drawing. West and north, so we really need that portion of it. So here we go. We'll use pink. It's 2 kilometers. It goes in the west direction, turns 30 degrees towards north. So something like this. And the length of it is 2. And the length of this one is 3. And the angle here is 30. Good. And finally, for the last one, vector C is just 1 kilometer south, so shorter than the rest. Magnitude is 1, and it's only moving in the south direction. So this is north, this is west. Okay, so when we're adding vectors, we are going to add all their components together, use that components to figure out where our final vector is. So in the first one, we are going to look at the east component and the west component of this vector. So we have AE, and we have a north. And I'm going to give it a vector sign. Okay, so for east, for the first one here, you can see that A is going in the same direction here. So it's positive east direction. And it's going in the east direction. So this component is 3. I'm not going to write all the units. We know that all of the units are in kilometers. And I know that my sign convention is already in this direction, so I'm not going to write them in all of the steps. I will make sure that my final answer has all of them included, but not every single step. In the north direction, well, this vector starts here and it only moves in east, doesn't move up or down, so this is going to equal to 0. That's it. For my next vector has components. It's got this component and it's got this component. So I have to figure out what those are. So I'm going to start with AE and I'm going to do AN as well. So for AE, in the east direction, we're looking at this component because this component is kind of in east. First of all, we know that it's going in the opposite direction to east, so I'm going to put a negative right away. And in terms of the magnitude or what the size is, I know the hypotenuse is 2. I know that this is adjacent to the hypotenuse. I know that this angle is 30, and I know that this side over here is adjacent to the angle. And since I have the hypotenuse and it's adjacent, I can use 2. Adjacent goes with cos against SOHCAHTOA. So I'll write SOHCAHTOA down for those of you who have forgotten. SOHCAHTOA. And we got the S, we got the C, we got the T, and here we got adjacent and hypotenuse, so we're going to use cos. So this is cos 30 degrees. And when I put this in my calculator, I'm going to get 1.73205008, and it keeps continuing on. And you can see that my values here are given in 2 significant figures, but this is not the answer that I'm looking for. I only round when I get to the very, very, very final answer, and this is not my very final answer, this is just an intermediate step. So if I were to round here, that rounding would propagate and get my final answer will be very far away from what it is. So I recommend that you keep this in your calculator. So try looking up to see how you can store numbers on your scientific calculator. And once you have that stored, you can just use it later. If you're too lazy to do that, then I suggest you use at least 4 decimal places, or maybe even 5 as you use your values in the next step. So anyways, that's kind of, I'm going to keep it as that. I'm not going to round yet until I get to my final answer. And AN, the north component, we can see that it's going in the same direction as our north, so it's going to be positive. So I'll just put a positive, you don't have to. And since this side is opposite to my angle, I'm going to use the sine. So this is going to be 2 times sine of 30, and that's going to give me 1 plus 1. And sorry, I did forget the negative here. This one is negative 1.73205008. Okay, for the next one, for the final vector, making some boo-boos here, so I'm just going to fix that up. And this is vector B, and this is also vector B. And now I'm working on vector C. This is going to have an east component to it, and it's going to have a north component to it. So for the east component, we can see that it's not actually moving in the east direction at all, so I'm going to give that a 0. And for the north direction, it's going down this way. My north is positive up. This is going down, so instead of using positive, I'm going to use -1. And that's it. Nothing else that I need to worry about. There's no angles, there's no components. This component is in the direction of north-south, so I can just use that. Okay, now that I have this, so the first step for solving these questions is to kind of sketch it. It helps. You can skip this step, but I suggest that if you're just beginning with these types of questions, to sketch it. And then to break things down into the east and north, or whatever set of components, you might have X, Y, you might have something else, break them down into their components like this. This was the most challenging one in terms of breaking it down into components because you had to use sine and cosine rule, but these two were pretty simple. And once you have this, your final vector, let's call it, I don't know, let's call it D. So vector D, it's also going to have a east component, and it's also going to have a north component. So to find the east component, I'm going to add all of the components here. So the east component of A, east component of B, and east component of C. So I'm going to have 3 plus minus 1.73205008. And you don't have to write all these numbers when you're actually writing it in the calculation, but make sure you are using the actual value in there. And plus 0. And once we have this, we can put it on a calculator and we will get 1.267949, and it just keeps going. And I'm going to keep that as that, and then I'm going to do the north component as well. And for the north component, I am going to add all the north components. So in this case, I'm going to have 0, I'm going to have 1, and I'm going to have a -1. So in this case, I'm going to have 0 plus 1 minus 1, and that's going to equal to 0. Now that I have the two components, I'm gonna I'm gonna draw them out. So I'm gonna move up a little bit. So in this case, my east component of my vector is in this direction, and it's got a magnitude of 1.267949. And the north component is 0. It doesn't move in this direction. So I don't have to have any components in that direction. So my vector ends up just being this, meaning that my vector D is going to be 1.267949 units long. And since my east direction is positive in that direction, I'm just going to keep it positive. My values were all given in 3 significant figures, so I'm going to round this up to 1.27 for 3 significant figures. My unit was kilometers, and my direction here, it doesn't have two components, so it doesn't have any angles. It's moving in the east direction, so I am going to say east. Okay, let's do one other question, and let's do this one now. This is the same question. We're just asked to determine A plus B, so we don't really need to care about the C component. So let's do the exact same thing as we did before. Vector A, 3 kilometers in this direction, and vector B is going to be the west direction, and then turn 30 degrees north. So it's going to be more like this, and it's going to have a magnitude of 2. Angle here is 30, so we're going to draw this component and this component, and we're going to have our direction to be positive east and north here. So I'm going to go through the first few steps that we did previously pretty quick. We are going to break this down into its components, A, E, and A north, and we're going to have vector B, E, and B north as well. For AE here, it's moving in the east direction, positive, so I'm going to put in 3. For the north direction, it's not moving in the north direction, so it's going to be 0. For the other one, for B, in the east direction, this component is actually going in the west direction, and this component over here is actually adjacent to my angle over here, so I have to use cosine for it. So this is going to be 2 cosine 30, and it's negative because it's in the opposite direction of east, and this is going to equal to negative 1.73250 dot dot dot. And for the north component, it's going the same direction, so it's going to be positive, and it's opposite to the angle, so it's going to be 2 sine 30, which is going to equal to 1. So I have the two components. These steps were exactly the same as the last one. And now the next step is also exactly the same. Let's call this vector D again. So D is going to have an east component, and the east component is found by adding the two east components in these vectors. That's going to be 3 plus minus 1.73205 dot dot dot. I'm going to use the exact value, and when I do that, I will get 1.267949 dot dot dot, and that's going to be the east component. And for the north component, I am going to say it's equal to, so it's 0 here plus 1. So I will have 0 plus 1 is equal to 1. Okay, good. I'm going to raise this up a little bit, and now with the components that I have, the components of my vectors in the east direction has a magnitude of 1.267949, and in the north direction it has a magnitude of 1. So it goes up like this, and it has a magnitude of 1. So actually, just for sake of making this a little bit easier, I'm just going to write the number down here, 1.267949. Dot dot dot. I'm using the exact value on my calculator. So the actual vector connects from beginning here. So because we're adding the two components here and there, and it starts from here and it moves here. So I'm looking for two things. I'm looking for its magnitude, so how big it is, and I'm looking at this angle over here, theta. So I want to figure out what this magnitude is and what the angle is. To find the magnitude, what I'm going to do is I'm going to use Pythagorean theorem. This angle is 90 degrees over here, and I have this side and this side. So the magnitude is going to equal to the square root of 1 squared plus 1.267949 squared. And I'm going to use the exact value on my calculator. And I will end up getting 1.6148, and this number continues on, and this is now the final answer that I'm looking for. So the magnitude of this vector and its angle. So this one is going to be, I know that all my numbers are given in 3 significant figures, so this is going to be 1.61 in 3 significant figures. I'm going to give it, it's got a unit of kilometers. And for the angle here, we can see we have the opposite side and we have the adjacent. So I'm going to use tan. So tan theta is equal to 1 over 1.267949. And theta is going to be tan inverse of 1 over 1.267949. And when I do this in my calculator, given that I have the proper unit, degrees, instead of radians, I should get 38.3 degrees in 3 significant figures. And again, this is an approximation. And this is it. So I have my angle here, and I know that I'm moving to the east direction, turning towards the north at an angle of 38.3. So to express my final answer, vector D, or vector A plus B, is going to equal to, the magnitude of this vector is 1.61 kilometers. And again, this is an approximation. And the angle for it is, starts in the east direction, we turn 38.3 degrees towards the north direction. And you could do 90 minus 38.3 to talk about this angle starting from north moving towards east as well. It's completely up to you. Both answers work. But here's how we complete these types of questions. And again, in terms of steps, we start, I'm just going to move up a little bit so you can see, we kind of start off by drawing them out, breaking them down into components, adding the components, drawing out the new components. So in this case, we had a positive value, so we went in the east direction, positive, we went in the north direction. Connecting the two, it makes a right angle triangle, and we have the two sides, so we can find its magnitude using Pythagorean theorem. And just going to move up a little bit again, and we want to find this angle. We have the opposite and adjacent side, so we can use tan theta to find this angle, and this is our final solution.